Good morning students, welcome to Mohan Rao Maths videos. Today we are going to discuss 9th Mathematics Chapter 1 Number System Part 1 video. In this Part 1 video we discuss all the basic numbers and their properties. Let us start with natural numbers children. Children, you know the counting numbers 1, 2, 3 etc. are called natural numbers denoted by n. So natural numbers n is equal to set of 1, 2, 3, 4 etc. Let us see the properties of natural numbers. What is the smallest natural number children? It's 1. And what is the largest natural number? We cannot say. So the largest natural number cannot be determined. And here I am going to tell you two formulae to find out the natural numbers between any two natural numbers just like a and b. And also I am going to give one more formula to find out the number of natural numbers from two natural numbers a to b. Between a and b you can have number of natural numbers is b minus a minus 1 where a is less than b. And to find out the number of natural numbers from a to b is given by the formula b minus a plus 1 where a is less than b. And also I want to tell you one more formula to find out the sum of first n natural numbers is n into n plus 1 by 2. Let me explain you with one example. For example, if you want to find out the sum of first 100 natural numbers, that means 1 plus 2 plus 3 plus 4 plus etc. 100 natural number sum we want to find out. So here n is equal to 100. The formula is n into n plus 1 by 2, that is equal to 100 into 100 plus 1 by 2, that is 100 into 101 by 2, that is equal to 50 into 101, 5050. So using this formula we can find out the sum of first any number of natural numbers. Coming to whole numbers children, the natural numbers along with 0 are called whole numbers denoted by W. That means first of all you take natural numbers. If you add 0, that set become whole numbers. Whole numbers are denoted by W. So W is equal to set of 0, 1, 2, 3 etc. Here also we see some properties of whole numbers. The smallest whole number is 0. Here also the largest whole number we can't say. So the largest whole number cannot be determined. And we can say all natural numbers are whole numbers. Yes children, there is no difference between natural and whole, only 0. I mean to say 0 is present in whole numbers, 0 is not present in natural numbers. That's why we can say all natural numbers are whole numbers. And one more property, the difference of any two consecutive whole numbers is 1. Yes children, take the two consecutive whole numbers 4 and 5. Their difference 5 minus 4 is equal to 1. Coming to integers children, integers set you can denote by I or Z. What the integers means, the set of whole numbers and their negatives are called integers. Here you see children, take the whole numbers first and write their negatives. For 0 there is no negative, for 1 negative is minus 1, for 2 negative is minus 2, for 3 negative is minus 3 and so on. All together this total set is called integers. Integers are denoted by the letter Z. Why we denote the integers by the letter Z means, here Z is known as Zahlen, Z-A-H-L-E-N. It's a German word which means to count. That's why we represent the integers by the letter Z. See some properties of integers. In this integers, this plus 1, plus 2, plus 3, plus 4 etc. are called positive integers. Whereas this minus 1, minus 2, minus 3, minus 4 etc. are called negative integers. Here the 0 is neither positive nor negative integer. That means we are not supposed to say plus 0. We are not supposed to say minus 0. 0 means only 0. For your convenience children, I'm going to represent the integers on a number line. If you see these integers on the number line, you can observe infinite positive integers to the right of 0. Yes. And also infinite negative integers to the left of 0. Coming to even numbers. You know, children, the numbers which are exactly divisible by 2, that means when you divide by 2, the remainder must come 0, are known as even numbers, denoted by E. So even number set E is equal to set of 2, 4, 6, 8, etc. Let us see some properties of even numbers. The difference of any two consecutive even numbers is 2. Yes, children. Take the two consecutive even numbers 2 and 4. Their difference 4 minus 2 is equal to 2. Correct. Next property. The sum or difference of any two even numbers is even. Let us take the two even numbers 2 and 4. Their sum 2 plus 4 is equal to 6, which is even. And their difference 4 minus 2 is equal to 2, which is also even. The product of any two even numbers is always even. Yes, children. Take the two even numbers 6 and 8. Their product means 6 into 8 is equal to 48, which is again an even number. Next, the sum of the first even natural numbers is n into n plus 1. Let me explain you this with one example. For example, children, I just want to find out the sum of first 10 even natural numbers. So here n is equal to 10. The formula is n into n plus 1, that is 10 into 10 plus 1, that equals to 10 into 11, that is equal to 110. So the sum of first 10 even natural numbers is 110. Next property. The general form of even number is 2n, where n is a natural number. That means every even number is in the form of 2n, where this n is a natural number. That means for n, if you give any natural number, 2n becomes an even number. Coming to odd numbers, children, the numbers which when divided by 2 leave a remainder 1 are known as odd numbers. So odd number set O is equal to set of 1, 3, 5, 7, etc. Let us see some properties of odd numbers. The difference of any two consecutive odd numbers is 2. Yes. For example, these are the two consecutive odd numbers 3 and 5. Their difference 5 minus 3 is equal to 2. Observe, children, difference is nothing but biggest minus smallest. The sum of two odd numbers is always even. Yes. For example, you take again 3 and 5. Their sum 3 plus 5 is equal to 8, which is even. The product of two odd numbers is always odd. Yes. For example, you take again 3 and 5, two odd numbers. Their product 3 into 5 is equal to 15, which is odd number. The sum of an even and an odd number is always odd. For example, you take an even number is 2, an odd number is 3. Their sum 2 plus 3 is equal to 5, which is an odd number. The product of an even and an odd number is always even number. For example, 4 is an even number, 3 is an odd number. 4 into 3 is equal to 12, which is even number. Next. Sum of the first n odd natural numbers is n square. Let me explain you this with one example. Suppose if I want to find out the sum of first 10 odd natural numbers, that means 1 plus 3 plus 5 plus etc. 10 odd natural number sum I want to find out. That means here n is equal to 10. So the formula is n square, that is 10 square is equal to 100. And next, the general form of any odd number is 2n minus 1, where n is a natural number. That means every odd number is in the form of 2n minus 1, where n is a natural number. That means if you give any natural number for n, this 2n minus 1 become an odd number. Coming to square and square root of a number. For example, you see, children, take the two same numbers 4 and 4. If you multiply them, you will get 16. So the product of two same numbers is called square of that given number, that we write as 4 square is equal to 16, where this 4 is square root of 16, that means root 16 is equal to 4. In the same way, 5 into 5 is equal to 25. So 5 square is equal to 25, root 25 is equal to 5. Let us see the definition. The square of a number is product of a number with itself. Square of 9 is 9 square, 9 into 9 is equal to 81. So 9 square is equal to 81, square root 81 is equal to 9. In the same way, square of 5 is equal to 5 square, 5 into 5 is equal to 25. So 5 square is equal to 25, square root 25 is equal to 5. Coming to perfect square or perfect square numbers. A natural number is called a perfect square if it is the square of any natural number. I mean, 36 is a perfect square because you can write 36 is equal to 6 square. For example, 1, 4, 9, 16, 25, etc. are all called perfect squares because these all numbers can be written as the square of some other natural numbers. For example, 1 is 1 square, 4 is 2 square, 9 is 3 square, 16 is 4 square, 25 is 5 square. That's why these are all said to be perfect squares. Whereas 21, 23, 29, 31 are not perfect squares because these numbers cannot be written in the form of square of other natural numbers. Coming to factors and multiples of a given number. I just want to tell you briefly, children. You take the numbers 4, 6, 8. You please say with what numbers exactly this 4 is divisible by. That means we'll say 1, 2, 4. 1 4s are 4, 2 2s are 4, 4 1s are 4. So 4 is divisible by all these numbers. That's why these numbers are called factors of 4. In the same way for 6, for 8. You observe one thing here. 1 is a factor of every number, and also every number is a factor of itself. And one more thing we can observe, the factors of any given number are finite, that means limited. Whereas coming to, if you want to write the multiples of a given number, simply you write its table. I mean to say, you multiply the counting numbers just like 1, 2, 3, 4, etc. with the given number. For example, if you want to write the multiples of 2, you write 2 1s are 2, 2 2s are 4, 2 3s are 6, and so on. That means I multiplied by the counting numbers 1, 2, 3, 4, etc. by 2. In the same way for the multiples of 3, 3, 6, 9, etc. For 5, 5, 10, 15, 20, etc. So, if you observe here, the multiples are not finite, they are infinite. Now see the definition. If a number x divides another number y exactly, then we say that x is a factor of y. For example, 6 divides 18 exactly, 6 3s are. So 6 is a factor of 18. Now see, number of factors of a given number is finite. I told you already. 1 is a factor of every number, and every number is a factor of itself. Every factor of a number is less than or equal to that number. You can observe that in the given examples. Coming to multiple, the definition. The product of a number and counting numbers, just like 1, 2, 3, 4, 5, etc. are called multiples of that number. That is, multiples of a given number which are exactly divisible by the given number. For examples, multiple of 5, 5, 10, 15, 20. So, multiples of a given number are infinite. That means number of multiples we will get for any given number. Coming to one more important, children, prime number. The natural number greater than 1 is said to be a prime number if it has only two factors, 1 and itself. Yes, children, prime numbers have only two factors, 1 and itself only, no other factors. For example, you see 2, 3, 5, 7, 11, etc. These are all said to be prime numbers because 2 has only two factors 1 and 2. For 3 has 1 and 3. For 5 has 1 and 5 and so on. That means 1 and itself only. You see here, the set of prime numbers is a subset of natural numbers. Subset means it's a part. Let us see some different prime numbers between some numbers. Prime numbers from 1 to 50, 15 primes. Prime numbers from 50 to 100, 10 primes. Prime numbers from 100 to 200, 21 we have. You can write the prime numbers between these two given numbers and you can check out them. Coming to twin primes. A pair of prime numbers differ by 2 are called twin primes. That means here I took one pair of primes 11 and 13. The difference 13 minus 11 is 2. Here also I took two primes 5 and 7. The difference 7 minus 5 is equal to 2. Here also difference is 2. This type of pair of numbers are called twin primes. Coming to coprimes or relatively primes. What the coprimes or relatively primes means? When two numbers do not have any common factor other than 1 between them, they are called coprimes. For example, I took some pairs here. For these two numbers, only the common factor is 1, no other common factors. For these two numbers, only 1 is the common factor. Here also 1 is the common factor. These type of numbers are called coprimes or relatively primes. Here the important rule is if two numbers are coprimes, then the two numbers are need not be primes. That means both can be prime or both may be prime or may not be prime. For example, you see here both are the primes. Here both are the primes. But here 4 is not a prime, 5 is prime. Anyhow, this pair is said to be coprime. Next, today the last topic, composite numbers. A natural number which is neither 1 nor a prime is called a composite number. That means, for example, 4, 6, 8, 10. These are all said to be composite numbers, which is not a prime and also not equal to 1. Those are said to be composite numbers. Here I just want to tell you one thing, children. For prime numbers, I told you there are only two factors, that is 1 and itself. Here for composite number, minimum 3 factors. Along with the 1 and itself, one more extra factor must be there. That means here we just tell you one note point, 1 is neither prime nor composite number.